Okay, after lunch on day 2. Everyone still awake? All right, good deal. So this talk is about API discovery. And the title's actually From Crawl to Run, but we'll make it more fun than that. So first off, to get started, anybody have a little uncertainty about what does API discovery mean? Nobody? A couple hands. Okay. Anybody think this is maybe like a moot topic? Like, because I know when I first got involved with API discovery, as a developer myself, I was just like, well, if I want to discover what's out there, I'll just look at GitHub. I'll just read the code. Like, why do I need a tool, or why do I need processes to help me discover this stuff? And actually going through this process led to kind of a crisis of confidence, even at one point. Do I really know what the hell I'm talking about? What is an API? What am I counting? So this is a really fun topic. I'm Rob Dickinson. I'm a VP of Engineering at Graylog, and I'm easy to find on LinkedIn or online. So why does API discovery matter? It matters because this is really the starting point for API security. API security should start with understanding your attack surface. We want to take that attack surface, we want to be able to describe that attack surface in terms of metrics. If we can measure the attack surface, then we can see, is it going in the right direction? Is it going in the wrong direction? But we can't have metrics without agreeing what to count. And I'll even have a fun little exercise in here that we can do as a group. What we'd like to do is we'd like to get to the place where we can make a statement like this about our APIs. We have X number of APIs, Y are new, and Z need attention. And if we can solve for X, Y, and Z, we'll be in a pretty good place as far as understanding what our attack surface looks like and understanding the places where we should focus our attention next. All right, so in a lot of talks, you hear all the theory behind the thing, and then at the very end, you get here's kind of the short answer. I'm going to start with the short answer. So I'm going to give you the stages of API discovery, and then we'll talk a little bit about each of these stages and some of the challenges that are there. But it's probably obvious that the first step is going to be to create an inventory. If you don't have an inventory already, you're not alone. A lot of folks don't. Or they don't trust that the inventory that they have is complete. Maybe it's something that you inherited, but that's okay. But creating that first API inventory is the crawl step. The walk step, then, is to track changes to that inventory over time as you go. And then the run stage is to track changes in risk. So you're not just talking about how many APIs changed, but you're now able to prioritize that to say these are the things that likely have the greatest impact on our security posture, and let's focus on those things first. Okay, so this is where I think things get kind of interesting from a philosophical perspective, because obviously what we want to do here is we want to be counting our APIs. We're discovering our APIs, we're creating metrics about our APIs. That means we have to make decisions about what it is that we're counting. And one of the biggest challenges in doing this is that really the best practices for APIs in general are not terribly well understood. We have to acknowledge we're in a bubble here, right? Everybody here is an API advocate, probably an API expert relative to other folks in your organization. But the metrics that we want to bring out of this API discovery process are really metrics for the entire organization. So we have to make sure that the way that we're counting these things and what we're describing is actually well understood. That alone presents some challenges. Also, for folks who aren't terribly technical, these APIs are crazy dark. You can't just hop on your browser, point your browser at a website, look at what the website is the way that we used to in the old days. Without a development background, it's very difficult to understand what APIs are, what they're doing, even answering this question of how many of them do we have. APIs also have a fast rate of change. So even if you knew what they were doing yesterday, they're probably doing something different today. APIs also have different development cultures. Again, for the people in this room, it's probably not a huge revelation that GraphQL developers and REST developers see the world differently. There's many other variations on that theme, right? Especially when you're talking to someone non-technical and they're like, can you give me the answer? Can you just tell me what APIs do? Right? You start to realize how hard a question that really is to answer. And the last one, which I really, was really a surprise to me. I thought I knew what APIs were, but as it turns out, even the whole concept of what an API is it's loosely defined. I thought I knew what an API was until I tried to count them and to get everyone to agree on what the count was. And then I realized, wait, maybe we're not using the right definition here. So let's try that as a group. And I apologize, this is a little bit of a vision test here. But let's pretend that I'm monitoring traffic on the network, and I see an API request, and it's a post request, and it's to this coinbroker.io domain, and looks like I'm registering a user. And then I've got a second request, and I'm getting a quote. And then I have a third request, and I'm placing an order. And then we ask the question, so how many APIs are there here? It depends, right? Does anybody want to say there's 3? About half the room. So, yeah. How many people want to say there's 1? Yeah, about half the room. So we've asked this question over and over and over with at different levels of knowledge, different levels of expertise. We get typically a 50-50 split, with about half the folks saying 1, half the folks saying 3. If anybody has an answer that isn't 1 or 3, I'd love to talk to you about how you're getting to that number. 27! It could be 2, yeah. Does that feel good? No, that doesn't feel good at all. What if this was like the GitHub API or some of the massive APIs that Microsoft has? So the answer then is either 1 or 1,000? Like, how can the answer be 1 or 1,000, right? That's crazy. So this is kind of the crisis of confidence part. Even when we tapped like API analysts, people like literally like folks at Gartner and Forrester and so on, we couldn't even get them to agree on how many APIs were present when we showed this example. When you really start to go into that and you ask people, well, how would you want to count your APIs? There's a bunch of really reasonable answers to that. One way, you could count the qualified domain names. You could count the method and path combinations. What are the unique routes? You could count the infrastructure. You could count the physical servers, the virtual servers, the VMs, whatever that is. Some folks, when you ask them to count their APIs, they're going to start doing that in terms of internal versus external, or east-west versus north-south, and that's the way that they want to count. There's another way, though, of looking at this, which we feel like is potentially the most powerful and actually answers this question most succinctly, which is to use a specification to count your APIs. And so then you get to blame that decision on someone else, right, who came up with the nomenclature. And we think that OpenAPI, obviously GraphQL follows kind of the same pattern as far as having a spec that describes the integration. But we really think that specification-based descriptions are the most beneficial. And when we take OpenAPI and we apply it to this example, most people will say that there's 1 API and it has 3 paths. And that now feels pretty good. Now, I realize at the same time, there's no reason why you couldn't do 3 OpenAPI specs for the 3 routes that we have here. And that is also completely valid. So even OpenAPI itself doesn't provide an incredibly rigid way of looking at this. But I think most people that have worked with OpenAPI would tend to agree that having one description for this, one spec for this case, is the more natural way to go. And certainly if we think about like the GitHub example or the Microsoft example, we'd rather have one spec for api.github.com than to have 10,000 for each of the route and path combinations. All right, so now that we've figured out what we want to count and that we want to do that on a specification-based basis if we can, then the next challenge is talking about tracking changes. So now that we have that initial API inventory, now we need to figure out how it's going to be changing over time. One of the things that comes into this then, almost immediately for most folks, is you just made a decision about what it is that you want to count, but now you start to realize, well, I need to put those things in different buckets themselves, because if we're tracking these things over time, then those metrics that we're tracking over time need to reflect the life cycle state of the API. So for example, we might have rogue or unmanaged APIs. Those are ones that are new. The development team stood those up without telling anyone, that kind of thing. These are rogue things. They need to be reviewed by the security organization. Somebody needs to be able to say that that's okay. That's kind of a life cycle denotation here. And we want to be able to say how many rogue APIs we have. We want to be able to quantify that risk. We also want to be able to describe what APIs are not supposed to be used at all. So the security team might say, this is a particular service. It's not cleared for corporate use. We shouldn't be using that at all. And so you want to have a list of those prohibited or banned APIs. And again, those are the ones that you're tracking over time. You'll have monitored or supported APIs that are the ones that are actively maintained by the organization. And then you have deprecated or zombie APIs, which is one of my favorite terms. Those are APIs that are basically lingering on your infrastructure. You know that there's newer versions of those available, and you'd like to get folks to use the new supported versions, but for whatever reason, they're still hanging out on those deprecated, those older deprecated versions. And so you can see that we've now moved from just creating an inventory to now having an inventory that reflects the life cycle of the APIs, of the infrastructure even, that's running these services. And so a lot of the discovery tools that you'll see, especially in the security domain, will have buckets like this. So you'll start off with basically your specifications, ideally, to describe the APIs. But then you'll have a rogue set, a prohibited set, a monitored set, a deprecated set, and so on. Now, this can be a lot of work, right? We've already said we wanted to do this on a specification basis. So what's the first problem? Where do we get the spec? And do we trust the spec that we get, right? So there's an art to that. We might have to go to the development team, or we might have to use network monitoring and reverse engineer the spec from the traffic that we're seeing. Those are good ways to do this. But if you want to go from crawl to walk to run to rocket ship, here's the really cool way of doing this. So if you're really trying to double down on continuous discovery, the single best way to do this is actually have self-describing APIs. So the same way that GraphQL does for introspection routes, add an introspection route for your REST APIs so that those REST APIs can be self-describing. That means that any of your discovery tools or your monitoring tools then will be able to go to that API, interrogate its API spec, and then be able to see if the runtime traffic ideally matches that descriptor, right? This is something, obviously, you see a lot with GraphQL. We're just starting to see this idea come into more REST APIs, but this is a really, really good pattern And in most cases, it's very, very cheap to add this kind of route to your API services. All right, so the last step in this process is to talk about risks. So now that we have our API catalog and we have our API catalog being refreshed as things change, and we're tracking our zombie APIs, and we're tracking our rogue APIs and all those things, that's going to give us a set of hard targets that we want to go and look at. Where risk scoring comes in is when we want to prioritize those targets relative to each other. So if we found a bunch of rogue APIs, or we found a bunch of prohibited APIs, or we found a bunch of user activity that represents a threat to our APIs, this is where we want to include that knowledge in the metrics and the KPIs that we have. So this is all trying to answer the question of how have recent changes affected the API attack surface? And what's really fun about this is now we're not just talking about the spec, we're not just talking about what the organization intended to deliver, but we're talking about what's actually happening on the APIs. So to get to this level, there's a very strong need for runtime monitoring of those APIs. That's not a new idea, right? NIST and OWASP have been talking about the need for sufficient logging and monitoring for just a few decades, right? We know that. But when it comes to APIs, we know that those runtime behaviors bring unforeseen risks. There might be data-related conditions, state-related conditions, all kinds of cases where 200 doesn't mean okay necessarily. We saw some examples of that yesterday. Those are all very real things. There's also the need to quantify here the usage of those APIs as much as the infrastructure behind those APIs. So we know that threats can arise from inside or outside the organization. You know, the classic model that we think of is an overseas attacker, right? But what do Gartner and Forrester say are the most likely attack vectors in 2024? Insiders and supply chain, right? So we need to quantify those risks. We're not just talking about at this level, we're not just talking about quantifying infrastructure anymore. We're really talking about quantifying the overall risk, the overall threat level associated with these. Unfortunately, there's no standard way to calculate risk scores. So this is something that pretty much every organization has to figure out on their own. There isn't something like OpenAPI that is the ready, easy to apply, standard solution here. Maybe there will be one at some point. That would be fun. We believe that the best way to calculate a risk score is to look at both the request and the response. This is something that if you're used to seeing risk just in a perimeter security perspective, then you're used to seeing risk from the request side. But the response is where the data leaks are. The response is where the unintended behaviors are in a lot of cases. That's where the stack traces are leaking. That's where there's system identifying headers that are being leaked out, all those kinds of things. The response is incredibly valuable when you're talking about runtime monitoring. And again, we want to use those lifecycle groups that we had because we want to be able to use the risk scores to help prioritize what the organization should actually be focusing on. So we started off with that statement about we want to be able to say how many APIs we have, how many of them are rogue, how many of them need attention. This is the kind of, so this is a screenshot out of our product, but you basically want to get to the same level of understanding. So for the different groupings of APIs that you have, you want to be able to assess the total surface area, and you want to be able to compare the risk of those digital properties against one another. And if you can't do this, then you're going to have issues about, you're either going to have things that you don't know about are happening in production, or things that you're just blind to. And that's what we're all about here at Graylog. Would love to talk to you after this talk about all the different kinds of inspections and data we can gather to help you understand your APIs, and API discovery being a really critical component in that whole story. Thank you very much.